Hello student, how are you? Hope you did the very well this RENEET UG 2026 paper, and this was a bit on the tough side, so we are here to discuss that paper, right? So let's discuss one by one, okay? So this is the first question. They are saying a particle of mass m moves along the horizontal x-axis from x equals to 0 to x equals to L. Okay, so this is a horizontal axis in which this point will be x equals to 0 and this point will be x equals to L, where the coefficient of kinetic friction varies. So we have the coefficient of kinetic friction is variable here, which is mu naught minus alpha x. Mu naught minus alpha x. That means if I put x equals to 0, I am getting this mu k as equals to mu naught, which is continuously decreasing, and finally at this point it becomes 0. Because as given that at x equals to L, this coefficient of friction becomes 0. So if I put this mu equals to 0, what is the x value I am getting? I am getting x value as equals to mu naught by alpha, which is also equals to L. This way you are getting the alpha value also. So if we need it, we can use this alpha value as mu naught by L. Anyways, back to this. So now we have to find out the work done. So any body which will be on this horizontal floor, the normal will be equals to mg and friction will be opposite to velocity, opposite to the motion. So this way we can say that friction force will be, if I took the convention in the direction of velocity as positive, opposite is negative, then I will say it is mu into n, which is telling me that it is minus of mu naught minus alpha x into mg. So calculate the work done. We know that it is force into displacement. Since this force is variable, so we have to use F into dx, which is giving me minus of mu naught minus this alpha value will be mu naught by L into x into mg into dx. And just put the limit from 0 to L. While we calculate this, first term will be mu naught mg into L. Second term will be mu naught mg into L by 2. As it is x square by 2, while putting the limit L by 2. So overall, and obviously minus sign is there. So overall you are getting minus of mu naught mg into L by 2. Minus of mu naught into mg into L by 2. Now, just compare the magnitude with the given term. It is mu naught mg into L by 2. If I compare this with n times of mu naught into mgl, then clearly this n value becomes 1 by 2. And the correct answer for this is answer number 4. Alright, the fourth option, 1 by 2. So, mathematics, little bit mathematics, the simple integration they are using. Okay, for this question. Let's move to the next question. Fine. The mean free path of the molecule of an ideal gas. So this question belongs to KTG, kinetic theory of gas. And you know that in the kinetic theory of gas, this lambda is proportional to diameter square, inversely proportional to diameter square, and also it is reciprocal to number density of the gaseous molecule, right? So this way we have to find out the ratio of n. So I can say n is proportional to 1 by lambda into d square. And to find out this Na by Nb, Na divided by Nb, what we can do, we can say this is lambda b by lambda a into db by da whole square. As given in the question, the diameter of the spherical molecule A. So diameter of the molecule A is twice of the diameter of the molecule B. That is given in the question. Also, mean free path of the molecule A. Mean free path of the molecule A is half of mean free path of the molecule B. So I can substitute these ratios here to get this Na by Nb thing, which is lambda b by lambda a. Lambda b by lambda a becomes 2 and dB by dA becomes 1 by 2 whole square. And overall, what we are getting? We are getting 1 by 2 as an answer. So here I can write down Na is equals to Nb by 2. N is equals to Nb by 2. Clearly, we have to go with the option 4. Option 4. All right. Absolutely. Directly theoretical based question. You should know this formula. It is root 2 pi d square into n 1 by, that is the formula of mean free path. And this is a ratio thing. So even if you are not remembering the factors, only thing you have to know that these are the factors on which this mean free path is depending on. Okay, let's move to the next question. This is question number 3. So two identical inductors are connected in the two different configuration P and Q, where the time varying current I flowing. The induced EMF, you know that in the inductor, first of all, the induced EMF will be L di by dt. So what we are interested in? The inductance and di by dt in the case 1 and 2. And if you see, they are finding out the potential, the EMF across AB. So that means the potential difference in case 2 is across this combination, and this is a series combination, but they are asking the potential difference across any single coil. This is L, this is L, this is L, this is L. If this current will be as a function of I, and let us say at some time the rate will be di by dt, then clearly you can say that for the case 1, which is your configuration P, if I say what is the induced EMF in the configuration P across one of the coil, then you will say, sir, it is L into di by dt. Magnitude wise, what is EP? L into di by dt. While in the configuration 2, which is case P, if I will take the same rate of change of current, or you can say this is I, these are identical, so it is I by 2. Same way, if the variation in the current here is di by dt, then the variation in the current in these two coil will be also half, which is 1 by 2 into di by dt in each. So I can consider any of the coil and I can just find out EQ, which is L into di by dt by 2, which is clearly EP by 2. Which is clearly EP by 2 in the second case. Alright, we have to find out this ratio of EP by EQ, EP divided by EQ, which is coming as 2. Alright, which is coming as 2. So 2 is given in the fourth option. That's why we are going with the right option as 4. Okay, so your third question is also completed. So hopefully you are getting the right answers, and the paper is also, till now, it is moderate questions, right? There is no very difficult question came, because as you can see that the second and third question is directly based on the definition, while the first question is needed little integration. And I am also telling you this is code 50. So I am just discussing the code 50 question paper. Next one. Fine. For sound wave, the number of notes for the fifth harmonic of open-ended pipe is n. Ab open-ended pipe, and they are talking about notes. So pressure notes we are talking about, let's say how it goes. So suppose this is open-ended pipe. You know that how the harmonics will be formed. Just say, for example, if this is a fundamental, it will be like this. If it is a first overtone or second harmonic, it will be like this. So you can clearly say that this is first harmonic, which is fundamental, this is second harmonic, in which how many notes you will find out? You will find out 2 notes. That means in nth harmonic, there will be n notes. So in the first it is 1 note, in the second it is 2 notes. Similarly, nth harmonic, how many notes will be formed? N. So fifth harmonic of open pipe, open organ pipe, how many notes will be there? 5 notes will be there. 5 notes will be there, which is the value of n. So I got the value of n. Now let's move to the closed organ pipe. So what about closed organ pipe? Closed organ pipe, if I made a fundamental, This is my fundamental. Open end is anti-node, anti-node, closed end is node. Right? Which will be, this is the node, this is the anti-node. Next will be after fundamental, which is first harmonic. Next will be second overtone, which is the third harmonic. Right? Which is the third harmonic. So third harmonic will be like this. These all diagrams will be the displacement node and anti-node diagrams. Okay? Mind it. So now here if you see how many nodes are there, so you can clearly see there are 2 nodes. Similarly, next harmonic will be fifth harmonic. I am just showing these diagrams just to follow one pattern. Okay? So this is the fifth one. Here also you can see this is the node, this is the node, this is the node. Means fifth is corresponding to 3 node, 3 is corresponding to 2 node, first is corresponding to 1 node. That means if we are talking about 2n minus 1 harmonic, then number of nodes are n. N nodes will be there. If I am talking about 2m minus 1 harmonic, then m is the number of node. So here we are talking about 9th harmonic. 9th harmonic, which is 2m minus 1. That means what is m here? M becomes 5. That means 5 nodes are there in nth harmonic of closed organ pipe. So now you got the value of m, you got the value of n. If I say what is the value of n by m, it becomes 5 divided by 5 comes out as 1. So the answer should be of this question is 1, which is in the option 3. All right, let's move to the next question now. That is my question number, okay. Solenoid, quite a simple question, absolutely directly formula. Direct formula. Solenoid inductance defined as mu naught into n square times volume. Yes or no? Volume. Up here, instead of volume, what is given to you? N is the number of turns per unit length, mu naught is the permeability, and for the volume, length and radius is given to you. So it is a cylinder, so what is its volume? It is area into length, and area will be pi r square into L. So I am going to substitute these values here. So it is mu naught into n square into pi r square into L. All right, which is going with the option 1. Definition, direct definition. All right, direct definition. Next is question number 6. Question number 6. Fine. So a particle moving along the straight line where the position is given by s is equals to alpha t minus beta t plus gamma. So position x, or which is represented by here as x s, which is given to you alpha t square minus beta t plus gamma. If I substitute these value of alpha, beta, gamma, which is 1, 6 and 5, so it is t square minus 6t plus 5. That will be your x value, position value. See, by the comparison, you can find, we can clearly see this is a uniform accelerated motion. And you know that uniform accelerated motion, Vt graph will be a straight line. So let's make the Vt graph of this, because directly we can get the distance by the Vt graph. What is dx by dt? Dx by dt comes out to be 2t minus 6. 2t minus 6. This is the velocity graph, which is a linear graph, 2t minus 6. That means its intercept will be minus 6 and its slope will be 2. Slope will be 2. Also, at t equals to 3 seconds, the velocity becomes 0. That means at t equals to 3 seconds, the motion is changing its direction. If I solve by the equations, it will be tough, because then we have to find out this position where it is at t equals to 3, then it is reversing, and for the average speed, we have to find out the distance. But here directly we can find out the distance just by the area thing. Now this is 3, so this value will be also 6, plus 6. And now you can clearly see that if I calculate this area and taking its magnitude only, I am getting the distance. So what is the distance? Distance is equals to half into 6 into 3. That is the area of one triangle. Both are symmetrical, upper and down. So this will be into 2. That means 18 meter is the total distance traveled by this particle in 6-second period, 0 to 6-second period. Now what is the definition of average speed? It is the distance upon time. So it is 18 divided by 6 gives you 3 meter per second. 3 meter per second will be my answer of this question, which is the option 3. And this is the easiest way to solve this type of question. Always, once you see that it is a VT graph, always like it is a linear graph, go with the graph. Graph, it will give you the fast calculation. Otherwise, you have to analyze this question too much if you want to solve it by equations. Okay, this question modern physics, and it is related to Q value. Fine. Q value is the mass defect. So we can say it is the mass defect delta M into C square. So delta M means it is the parental minus daughter elements into C square. Now if you see uranium mass is 238.050 minus. In the daughter element there is thorium and helium. So if I put these values 234.043 plus 4.003, this is giving me the mass defect. This difference of parental minus daughter element is giving you mass defect into C square, which will be, if I calculate this, it is coming something around 0.004 something around. Okay. Let me give you the exact value. So 238.05 minus 234.043 minus 4.003. It's exactly, it is coming 0.004 AMU into C square. Atomic mass unit into C square. To convert this unit, we have the factor. Directly we can write down, this is as 931.5 MeV by C square. C square will cancel, answer will come in MeV, as it is given also here. So when you calculate, this is coming as 3.726 MeV. Converted into kilo, it is 3726 keV. Alright, so we have to find out the answer in kilo electron volt. That's why there will be no decimal required here, and the answer will be 3726. Okay. Move to the next question. So, direct question again, only little calculation because decimals and everything. So, it might take you 1 second, 1 complete minute, but calculation wise and concept wise, very easy question. Move to the next one. A beam of light falls. Okay, so whenever you see the questions of graph, it will be a bit difficult because interpretation is required. But if you read the question carefully, you will very well understand. It is a case of photoelectric effect. So this is the photons which is falling on that metal target, and as a result, photoelectrons will be ejected out from the metal. So now power of the light. Power of the light means they are talking about this energy of the photons. A power of the light will be starting to decreases linearly. You know that this is HF. That means if this power will be decreasing, that means frequency is decreasing. Is it? No. It's not like this. They clearly said that same light will be used. So that means it is not the case. That means number of photons are changing, not the frequency. Not the frequency. So HF is the energy of each photon. Each photon. And if I want to decrease it, that means number of photons which is falling per unit time, that will be decreases. to decrease the power of the light. So what we are basically doing in this question, frequency remains same while this number of photons per unit time is decreasing. As a result, this power of the light will be decreasing. If number of photons are decreasing, definitely number of photoelectrons which is ejecting out is also decreasing. Which is the direct effect on the saturation current. Which is the direct effect of the current. So here current will be also decreasing in the circuit when this is meeting to cathode, and then as a result you are getting the current in this circuit. So this current is directly affecting, because number of photoelectrons ejected is less, definitely current will be also less. So this is how current graph will be linear graph. While frequency is not changing. So when frequency is not changing, clearly stopping potential remains same. So stopping potential will be constant only. So current is decreasing, stopping potential becomes constant. Clearly I will go with the option 1 here. Alright. Then comes to the next question, basic theory of photoelectric effect. Next question, okay. 3 identical capacitor P and Q and S, each of the capacitance C are connected to the battery of voltage V. If the energy stored in P and total energy of the system is UP and UT, find out. Now you know that in parallel voltage is same. So voltage across this is V. And voltage across this branch is also then V, total drop. That means how much drop is through each resistance, each capacitance, it is V by 2 because they are ideal. So now you have C and C, all are identical. We can find out the potential energy stored in the capacitor P as half CV square, C Vp square. And this is half into C, Vp will be V by 2 whole square. That gives you CV square by 8. Whereas to find out the net or total, we have to write down half into C equivalent into V square. Right? C equivalent into V square. So for the total. C equivalent in this case, 2 are in series, that means C by 2. 1 is in parallel, that means 3C by 2. So C by 2 plus C becomes 3C by 2. So 3C by 2, if I put it here, half into 3 by 2C into V square, that is giving me 3 by 4 CV square. We have to find out this ratio, UP by UT gives us 1 by 8 divided by 3 by 4. And I got 1 by 6. So 1 by 6 is the right answer, going with the option 4. Alright, student. Yes, little calculation, but yes, definitely a direct question of series and parallel. Move to the next question, question number 10. Again, very standard question of Bernoulli's equation, very standard question of Bernoulli's equation. So you have these two cross sections. Here if the velocity is V1, here is the velocity V2. Then first the continuity equation says that A1 V1 equals to A2 V2. A1 V1 is equals to A2 V2. A1 is 40. V1 is equals to A2 is 20 into V2. That means twice of V1 is equals to V2. The first equation which we are getting is this one. Second is Bernoulli's equation, same horizontal level. So no head equation means no rho GH term is there. So we can say P1 plus half rho V1 square is equals to P2 plus half rho V2 square, which can also be written as half into rho into V2 square minus V1 square is equals to P1 minus P2. Now, here it is half into rho. If I put this V2 as twice of V1, it will give me 4V1 square minus V1 square. And you don't need to see that P1 is greater or P2 is greater, because anyways this value cannot be negative if this is positive, right? So I will take the direct magnitude of the pressure difference, which is given to you as 15 Newton per meter square. So till now we are dealing with the MKS unit. That's why it is 3 by 2 into rho into V1 square. That will be 15. So V1 square is equals to 15 means 1. This is 10 by 1000. This is 1 by 100. That means V1 I am getting as 1 by 10 meter per second. Now I am going to convert into centimeter, so it is 10 centimeter per second. And reason being, I have to find out the flow rate in centimeter cube per second as given in the question. So that's why you know that flow rate will be dV by dt, and dV by dt will be area into dx by dt, and that's why this is nothing but A1V1. A1V1 or A2V2, right? So basically your equation of continuity is nothing but flow rate. Flow rate is constant in a streamline, that's why we are applying this. So what is A1? A1 is 40. What is V1? That is 10, and all are in CGS unit. That's why the answer will also come in CGS as 400 centimeter cube per second. That will be the flow rate, which is option number 4. Very basic question of Bernoulli's equation. Almost in every class, every phase test, this type of question you face many times, okay? Weekly test also. Move to the next question, which is question number 11. A current I0 flows through the metallic circular loop of radius r as shown in the figure. Alright? Find out the magnetic field at the center. Most of the students made a mistake that they said, sir, this is like at the center, it should be 0 because this is very standard question again. But provided if the identical loop is there. This is not identical, as they have clearly said that this resistance of ABC is half of the resistance of ADC. So if this is R1, this is R2, this half is R1, this half is R2, then they have clearly said that R1 is equals to R2 by 2. Right? Half of the ADC. So this resistance and this resistance is not same. That's why when I current is coming, this I is different, this I is different. So if I named it as I1, if I named it as I2, then I1 by I2 ratio will be R2 by R1, which is 2:1. That means I1 will be equals to 2/3 of I or I0, and I2 will be 1/3 of I naught. Now we can write down the formula of half loop. So what is the magnetic field at the center because of the semicircle? It will be mu naught I by 4R. Alright, mu naught I by 4R. So I just named it as 1 and 2. So what is B1? Because of I1, it is mu naught into 2I by 3. 2I by 3. No, 1 minute. Resistance, which resistance is more? R2 is more. Okay. R2 is more, so current is less. So fine. So this is for R. And this is giving you outward current, outward magnetic field, because current is anti-clockwise in this loop. Where is B2? B2 will be mu naught into I by 3 by 4R. That is into, because in this loop the current was clockwise. Clockwise current gives you the magnetic field at the center into. So I have to subtract them. So for B net at the center, I have to subtract them. B1 minus B2. Actually, vectorally we are adding them, but since direction is different, so we are subtracting them. So 2I by 3 and I by 3 will give you I by 3. So mu naught into I by 3. And in the denominator, you have 4R. So 3 into 4 becomes 12R. So mu naught I by 12R will be your right answer for this question, which is clearly option A. Answer is first one. All right. Right. For this question, if you do the basic questions of magnetic field and you are very well aware of the directions, how to find out, how to distribute the current in the parallel combinations, easy question then. Otherwise, little of moderate side. Next one. In the measurement of viscosity of the liquid using terminal velocity experiment, the spherical ball of the same radius having different density are used. Fine. So variation of the terminal velocity to the ratio of density of the spherical and the liquid. So again, direct formula of terminal velocity. What is the terminal velocity formula in Stokes law? 2 by 9 eta r square g rho minus rho B minus rho L. Okay, this rho B is the density of the ball, material means. If it is material, I will represent it by sigma, and liquid is given by rho. That means I am changing it to sigma and rho. Right? Then you take this common, so you can write down this thing as a 2r square g by 9 rho into eta. This is sigma by rho minus 1. Alright. Now they are saying that the variation in the terminal velocity means Vt, and with density of the ball to the density of liquid means this rho sigma by rho. What is this sigma by rho thing? So they want to make a graph between this versus sigma by rho. That means one I have to treat it as y, one I have to treat it as x. So now you can see that this is a straight line which is having negative intercept. That means x coordinate will be starting, or x intercept will be starting from x equals to 1. So that means if I extend this graph should be like this. It is starting from negative, but then from 1 it will be this. But they just want to see from 1 onwards. That means my graph will be this one. Can you see that? This I don't need to focus, this portion. So it is starting from 1, and at 1, the intercept will be, y-intercept will be 0. At 1, y-intercept is not 0, so this is not correct. At 1, y-intercept is not 0, so not correct. At 1, y-intercept is not 0, and even this is not a straight line also, which is inclined straight line. That means correct option will be 1 only. Understand? So formula is there, only this quantity you have to read, that it is the graph between Vt versus sigma by rho, which is my linear graph. Fine, move to the next question. Okay, two planets P1 and P2 are having the equal mass and the radius R1 and R2. The escape speed is V1 and V2, then what is the ratio? So you should know the formula of escape velocity. Escape velocity formula will be under root of 2gm by r. Alright? That means escape velocity is directly proportional to 1 by root r. As you can see that mass is given to you same. So mass is given to you same, that means what is V1 by V2? That will be clearly under root of R2 by R1. Equal masses are given, so this 2gm value will be constant, directly proportional to 1 by r. What is R2 by R1? From this equation, R2 by R1 is 1 by 2. That's why this is 1 by 2. That's why this is 1 is to root 2. 1 is to root 2. Okay, this is V1 by V2. What they are asking is V2 by V1. Yes, this mistake can be done because 1 by root 2 is also there and root 2 is also there. Be careful. So V2 by V1 will be what? That is root 2. That is root 2. Which is option 3. Next one. Gravitation is the simplest one because direct questions are there. Escape velocity question is also direct question of expression, and this is your very well known Kepler's third law. Time period of revolution of the planet is directly proportional to orbital radius cube. That means what is this T? R to the power 3 by 2. Direct answer. Right? And hopefully everybody did correct only this question. Fine. Move to the next one. This is pretty good. This question is pretty good. Means for this question you need to analyze it properly. So two infinitely long wires A and B carries the current I and 2I respectively in the same direction. Fine. You should know when the two wires are having the current in the same direction, what they do. Attract or repel. So you can say, sir, because of this I1, the field will be here into, and then if I apply BIL, what I'm getting the force will be attractive forces, right? And what is this force per unit length comes? This force per unit length expression comes as mu naught I1 I2 by, tell me, it is 2 pi r, because BIL. So B is this, IL. L will be down, right? Okay, so this force per unit length between the two parallel wires you should know. Now let's come to the question. A wire A is having uniform mass density lambda, lies on an insulating floor. Fine. Wire B is kept fixed at a height h. Okay. So this wire B is fixed. Wire B is not hanging. It is fixed. Fixed. And it is carrying the current 2I. That is B. Then there is a one wire which is lying on the floor. Lying on the floor. This is A, which is carrying the current I. So it will be pulled by this B, as force per unit length will be this one, right? So this is pulled by this force. So what is the force? Mu naught I1 I2 by 2 pi r. What is r here? This B will be hanging at a height h. Hanging means fixed. Fixed at a height h. Apart from this, what else is acting on A? The lambda is also given, which is the mass per unit length of this wire that is given to you here. So clearly there will be mg down. They are saying find out the minimum magnitude of h. As h is less, force will be more because it is reciprocal to r. So I want to keep the h minimum to minimum so that this wire will not leave the surface. Not leave the surface means its mg will be balanced by this force and there will be no normal. Normal is just 0 because it is placed on the floor. Right? So that means I can say this force will be equals to mg, or indirectly you can also say that the force per unit length will be dm by dl into g. Because if force is per unit length, then mass is also per unit length. Right? So this value will be mu naught into I into 2I, I1, I2 by 2 pi h. Because r value will be your h. That is equals to dm. dm by dl is lambda. Lambda into g is your answer for this question. So what is h? H is coming as mu naught into I square divided by pi into lambda g. Okay, mu naught I square upon pi lambda g. Let's see which option is matching. 1 by 2, 2, 4, not correct, 1. Okay, mu naught I square by lambda pi g is the right answer, option 2. Alright, so I discussed first 15 questions, right? And I hope that all those 15 questions you understand very well, and in the exam you did correct also, okay? All the best. Rest of the question, the other teachers also come to discuss. Thank you very much.
Hi, this is Sita Ramaro, Senior Faculty in Physics. Now I am going to explain the RENEET 2026 question numbers from 16 to 13. Okay, shall we start? Right, this is question number 16. In this, an ideal Zener diode with a breakdown voltage of -3 volt is reversed biased with a negative voltage -5 volt. The magnitude of voltage difference between B and A. So don't get panic. This is a circuit where 5 volt battery is there and the Zener diode of breakdown voltage 3 volt. As per this picture, out of 5 volt, 3 volt is used to make the diode conducts. Remaining 2 volts will be here. No need to worry and don't think too much about this particular problem. You should know this is a reverse bias diode because of positive plate is connected to N side of Zener and negative plate is going to P side of the Zener. So if you know clearly it is a reverse bias diode, then the problem is solved. So no issues. And next, this is question number 17 and this is from adiabatic expansion Here 1 mole of a gas with gamma 5/3, temperature is decreased from 60K to 50K. The work done by the gas in this process is, and capital R value is also given. Okay, so this is also a direct problem. No issues are here. In adiabatic process, the work done is NR by gamma minus 1 into T1 minus T2. Here N is 1, so no issues. R value 8.3 and gamma value 5/3 minus 1, T1, T2, the initial and final temperatures. Okay, just with a proper and simple calculation, you will get the option which is given as 124.5 joules. And next we are going to question number 18. It is from dual nature of matter, especially about photoelectric effect, and here 3 wavelengths were given, named 1, 2, 3. Okay, so those 3 wavelengths are threshold wavelength of those particular materials, and the incident wavelength is given as lambda. But there is a condition. If the incident wavelength is less than the threshold, we will get photoelectric effect, and if the incident length is greater than threshold, we don't have photoelectric effect. That's why before entering into this problem, we must segregate, yes, for which condition there is photoelectric effect and for which there is no. So in the first case, the incident wavelength lambda, if you just reverse it, the incident wavelength lambda is greater than lambda 1, where lambda 1 is the threshold wavelength. That means this particular case linked to no photoelectric effect. So there is no photoelectric effect and no emission of electrons. Therefore, there is no need of stopping potential. That's why the stopping potential in this particular case should be 0. And next, remaining 2 cases. In the remaining 2 cases, lambda here is less than lambda 2. Lambda is much less than lambda 3. That means in both cases there is photoelectric effect, but here incident energy is very much more, so velocity is more, and stopping potential is also more. That means V3 is highest of all. Here V2 is there, but when compared to V3, V2 is little less. That's why 0, more and less. From this we can pick option number 1. Because of the relation between V2 and V3, it should be V2 less than V3 and V1 equal to 0. So it is also a very simple one. Now look at sum number 19. It is also from dual nature. There it is given like 20 electron volt energy for a photon and for a electron. Then find the ratio of their momentums. Yes, for a material particle like electron, whenever you know kinetic energy, you should use this particular one, root 2m ke. This is from basic definition, or else we can write, because we call it as energy in general, we can go with this equation. And for photon, as you know, energy of photon obeys E equal to Pc. Here P become E by C. So this is momentum of photon. Let it be equation 2. It is momentum of electron. Make it as equation 1. Just if you divide, it will become P by pH, and when we get this ratio, it look like, just after a simple cancellation, root E and E, it will become C times root of 2m by E. Before substitution, think about C value 3 into 10 power 8. Mass of electron 1.6 into 10 power minus 19. And energy given 20 electron volt. Electron volt means 1.6 into 10 power minus 19 joule. Okay, and what we are missing here, sorry, this mass, this is charge written, that is mistake. Mass of electron is nearly 9 into 10 power minus 31 kg. After substituting all these things, the final value we will get like 900 by 4, which is finally goes to 225. This ratio is nearly 225. So next problem we are going. Look at question number 60. It is from practical physics. Which of the following measures requires index correction? So it is basically from optical bench. In your physics darkroom experiments, determination of focal length of lenses and mirrors, there is a bench called optical bench, and on the same bench we have source, screen, light, whatever the lens places, mirror places, etc. So on the big optical bench, whatever the corrections we call index corrections or bench corrections. That's why it is from the practical physics. Beware of the practical knowledge also to answer these questions like this. And now look here. There is 21. A unit positive charge is taken slowly through an infinitesimally thin tube inside a charged dielectric sphere. Dielectric sphere in the sense it is a non-conducting sphere. The charge is moved from initial point A to a final point B. It is initially at 2R and it is finally at 3R. So in any electric field, whatever the work done, that equal to W equal to Q times of potential difference. That means potential at final point minus potential at initial point. Because the charge given is 1 unit, don't worry about it. And for an outside point, whether it is a good conductor, bad conductor, leave it. For an outside point, we have the potential as 1 by 4 pi epsilon naught Q by R only. So it is 1 by 4 pi epsilon naught Q by RB. It is 1 by 4 Q by RA. Okay, take Q common. Here Q is charge of this particular sphere and 1 unit is the charge which was moved. So this Q, the charge moved was taken as 1 and the Q which is from in the potential term is taken as Q of this particular sphere. Okay, Q common and 1 by 4 pi epsilon naught common. Here you have RB minus RA. Okay, but the given answer is in this form. So in order to convert that, we need to go for substitution. Remember, the work done equal to Q. Q means charge stored inside the sphere because it is a non-conducting sphere. Throughout the volume there is charge. So it is rho times volume. As usual, denominator has 1 by 4 pi epsilon naught. And final distance 2r, and do the cancellation, you will get rho r cube by 3 epsilon naught. From here, we will get 1 by 6r. Do the required cancellation, you will finally get rho r square by 18 epsilon naught. And once again check into this problem. In that place, what is given here? N. So the n value for this particular problem is 18. Okay, now we are going to the next one. So look here. This is from ray optics. There are 3 liquids. Refractive index of this one is 1, second one 1.25, third one 1.5. 2 observers, one is from first liquid, another from is the last liquid, are observing same O. Because it is 5 centimeter, just look at from the boundary, this distance is 2.5, this distance is also 2.5. Okay, for similar observation, from medium R, the apparent depth is H2, from medium P, the apparent depth is H1. What is the difference in the magnitudes of H1, H2? That is the question given. Okay, so this is from refraction, especially in refraction, when we have object is in denser, observer is in rarer, log the cases, we can solve. Okay, the first one, for the first case, from medium P, when he is observing from medium P, P is a rarer and this particular medium is a denser. So for that, there is a fixed format also, mu of the denser by mu of the rarer equal to actual distance. That means whatever the distance we have in actual by apparent distance. So mu denser by mu rarer equal to actual distance by apparent distance. Substitute the values. Mu of the denser, here the denser one is 1.25, rarer is 1. D is the actual distance, which is 2.5, and D dash is the apparent one. So the D dash, which is the apparent one, equal to 2 centimeter. That means this object, when observing from P, look like it is at a distance 2 centimeter. Then what about for the observer in the second medium? We will see on the next page. Remember these values, 1.5 and 1.25. Or else we can finish that here also. Write mu denser by mu rarer. And this is the case where the object is in rarer and observer is in denser. In this case, you will get the reverse of it. D dash by D, that means apparent by real. So here out of these two, denser is 1.5, rarer 1.25, D dash we should know, D is as usual 2.5. Cancel, do the needful to get D dash equal to 3 centimeter. So they are asking. So for our sake, we are taking like D1, D dash, but here in this problem, it is H1, this is H2. What is the difference? Just we will get the difference in the magnitudes is 1 unit only, that is option 2. Okay, next one. Look here, this is from oscillations topic. In this particular thing, 2 particles are fixed on a circular wire of radius is fixed on a horizontal plane. So this is a circular frame. On these 2 particles start moving with uniform angular speeds and meet again. So initially they were at pi by 2. That means with this line pi by 2 means they started here A and finally they meet here B. Okay, in both cases when they are started from A, their momentums are in opposite direction, and when they are going to meet, there also their momentums will be in opposite directions. Okay, so in this particular case, if you take this particular direction, linear velocity v, and here linear velocity v, you take this angle as theta and this angle as 90 minus theta. By using component method or by using whatever the parallelogram law, we can use both for addition and subtraction. You can get in component methods or the total of these two become, that means the net momentum become 2mv cos theta. That means the net momentum of this particular problem obeys cos theta. So cos function. And moreover, when theta equal to pi by 2, it is equal to 0. Theta equal to minus pi by 2 is also equal to 0. So look at a particular graph which can show that which is of the cos nature, and initial and final momentums are 0. So the initial and final momentums are 0 in this particular option only. So just by doing components or like a parallelogram law of addition, you can also do all these things. And look at 24th one. Temperature of a sphere of radius r is increased by a small amount, delta t. The linear expansion coefficient is given as alpha, asking approximate increase in volume of the sphere. Very simple it is, and we know delta v equal to v gamma delta t. This is from the great definition of coefficient of volume expansion. But in this problem, in no place gamma was given. That's why you need to assume alpha in place of gamma. The relation between alpha and gamma is 3 alpha for all isotropic liquids. Expression for volume of a sphere, then 3 alpha, then delta t. 3 get cancelled, so your value should be like 4 by 3 pi r cube alpha delta t. So it is also from the very basics of thermal properties of matter. And now come to problem number 25. In this particular problem, there is a cork, like a wood-like substance. It is floating. Any solid object, in order to float, it must have some of its volume buried inside the water. That means immersed. In this particular case, the weight of the body is balanced by force of buoyancy. Okay, then in order to have oscillations, it must be displaced from this particular position. That means either by lifting or by pushing we can achieve that. That's why just assume this was pressed a further distance y, so that the additional buoyant force, the buoyant force is nothing but volume of liquid displaced into density of the liquid into weight. This will be the expression for buoyant force. So the additional buoyant force here produced, we can take like cross-sectional area, and whatever the distance that was now pushed further is y. So it gives you volume of the body mass into density of the liquid. Here the density of liquid, they are using the symbol rho, say take rho, and it is C. So this buoyancy force now acts as a restoring force. That's why in terms of directions, here also we can put minus, because whatever the moment you give, that means the displacement, buoyant force now is acting opposite to that. Equate to, yes, we know in springs or etc., we know the relation for restoring force F equal to minus ky, then this minus stands for direction, that is removed, and y. So finally what we have, k equal to a rho z. Once we know k value, we can go to the standard equation, 2 pi root m by k. It is the time period of a loaded spring system. Here also this acts as a spring system, no problem. That's why k value taken as a rho c. So the relation between t and rho is only our option. So t proportional to 1 by rho or rho proportional to 1 by t square. Just go on. Do it now. Rho 2 by rho 1. T1 by T2 whole square. T1 in place of T1 take T, in place of T2 take 2T to get 1 by 4. So nothing new. It is also from a standard model only. Now look at 26. Here it is from vernier calipers, and almost very rare they will extend the problem up to 0 error. But here unfortunately 0 error is given, but there is a confusion among the standard model, whatever in the books, and the actual way of calculating error. That's why there is an ambiguity, there is a confusion. So when there is nothing between jaws of a vernier calipers, if the vernier calipers jaws were closed, then the main scale 0 should coincide with 0 of vernier. If that was not happened and the vernier 0 lies on left side of main scale, that is called negative 0 error. Right side if it lies, that is called positive 0 error. So here the vernier scale shifts to the left of the 0 of the main scale. That means this vernier 0 is not on exactly 0 of main scale, it is on the left side. Left side means the negative 0 error. Okay, there are two things. Actually what was given to find the 0 error, which is negative, is total number of divisions in the vernier scale minus the coincidence, the number of the vernier division that was coincided into least count. So total number of divisions 10, coincidence is 4. As usual, it is an ordinary vernier calipers. Okay, the one value of main scale division is 1 mm and there are 10 divisions. So the least count of vernier scale is 1 by 10 mm. That means 0.1 m. Finally, it comes like minus 0.6 mm. Okay, and they are given the length measured is 1 centimeter and they are asking for actual length. So length measured is 1, actual length. So in order to get the correct length of this, whatever you measured, for that 0 error must be added. That means for positive error, the correction is negative. For negative error, the correction is positive. So the 0 correction, it could be 0.6 mm. So the final reading is whatever you measured, 1 centimeter plus the correction that is to be added. Finally, it comes like 1.06 cm. Nowhere we can find the answer. This answer was given from another model of 0 error calculation. That is, for negative error we can take minus n. That means directly we take the number of the division coincidence. So from that you will get minus 0.4 mm and the correction is plus 0.4 mm. So this kind of answer we have this is mm, and finally when you add the total value become 1.04 cm. So maybe it was given as the key, but practically there are two issues, so it was announced as a bonus. And next, this is from system of particles concept. A solid sphere of radius capital R. So A have a radius capital R and B have a radius small r. In those pictures, they want to know moment of inertia. In the first picture, so center of A is the axis. That's why, because A axis is passing through A, I can take as moment of inertia IA. Okay, now for the sphere of radius capital R, it is the own axis or natural axis passing through its center. Because it is a solid sphere, the moment of inertia passing through its own axis become 2 by 5 capital mr square. But for the sphere B, this is the same axis, but it is out of the body, and the distance between center of B and the axis is capital R plus small r. So by using parallaxis theorem, we can find this. Moment of inertia of capital B about this particular axis, we can take like, first write moment of inertia of the body about its own axis. That means it is a sphere of radius small r and mass small m. So go to like 2 by 5 small m r square plus, according to parallaxis theorem, there should be mass times square of the distance. That means small m into square of the distance between the two axes, capital R plus small r. And then go to second case. In the second case, B is the axis. That means its own moment of inertia is 2 by 5 mr square, because axis is passing through that only. But whereas it is far or outside for B, so that's why for B, moment of inertia about its own center 2 by 5 mr square into mass times capital R plus small r here also. Okay, by subtracting these two equations, we will get the answer. Okay, look at this 28th one. There is a simple harmonic oscillator. The mass of the particle is small m, spring constant is k. At a given instant, extension of the spring is x meter and the speed of the particle is v. On the xv plane, the graph v as a function of x is a circle. So that means we need to imagine, or we need to consider, there is a graph between x and v. Okay, this we can get from law of conservation of energy. Here body and spring both are in motion. That's why we can get the total energy of the particle as the sum of two things. Energy of the particle, which is from half mv square, energy of the spring, which is from half kx square. Okay, total energy is a constant in all these systems. Okay, then, okay, this total energy is taken as symbol E, and that is sum of two terms, body's potential energy and spring's potential energy. Sorry, body's kinetic energy, spring potential energy. Okay, because the graph was mentioned, generally the nature of the graph between x and v in SHM is a ellipse. Okay, here it is given like a circle. Okay, ellipse become a circle whenever there is semi-major axis equal to semi, minor axis. So we need to look into that. So divide this equation with capital E and rearrange the terms. Then identify this look like y square by b square plus x square by a square equal to 1. So it is actually an ellipse. But if a equal to b, it gives you a circular shape. That's why equate whatever the terms in place of a and b. That means this root 2e by em become b and root 2e by k become a. Just if you equate these two, you will get a nice relation m equal to k. So this problem is also prepared based on graphical knowledge in SHMs. Okay, so this is the way to solve a problem. And now look at some number 29. It is from optics. First of all, there is an object which is at a distance 30 centimeter. We have a lens system, two lens system. So for the first lens system, you can take object at 30 centimeter and focal length of the first lens, which is plus 10. Okay, so you can make best use of lens formula 1 by v minus 1 by u equal to 1 by f. As per this particular problem, u is on the left side, or which distance we need to measure opposite to direction of incident light. From that it is minus, and focal length is also plus because it is a convex lens. So finally, if you rearrange these terms, you will get v equal to uf by u minus f. So u value 30, f value 10 by 30 minus 10. So totally it gives you 30 into 10 by 20. That means 15 centimeter, which is plus. Here, this is the negative side of distance, this is the positive side. That means this particular image forms at a distance of in total 15 centimeter from L1. That is 12 centimeter from L2 because of this 3 centimeter gap. So again, you need to use the same uf by u minus f. Use 12 as u and minus 10 centimeter as f. Then you will get this particular answer as minus 60, and minus 60 stands for left side of the concave lens. So if you get minus here, that is on left side, positive here, that is on the right side. So it is also well planned from lens formula. And now look at this particular problem. There is an alternating voltage. Yes, we have to compare this with V equal to V naught sin omega t. And this is an LCR series. They want to know current amplitude. That means maximum value of current. That means I naught they want to know. Whenever LCR circuit is there and they are mentioning maximum amplitude means, first of all, check whether there is a chance for resonance or not. How we can check? Yes, if XL equal to XC, that means omega L equal to 1 by omega C, or omega equal to 1 by root LC, anything, or VL equal to VC. By checking any one of this, you can say the circuit is in resonance. So I'm directly going to this particular omega equal to 1 by root LC. Omega given to us 2 into 10 power 3. Just wait whether this root LC is also giving the same or not. L value 10 milli means 10 power minus 3. Capacitance 25. Micro means 10 power minus 6. If you substitute this, you will also get the value exactly equal to 2 into 10 power 3. That means this is a resonance LCR circuit. Then go ahead. If you want peak value of current, that is also peak value of voltage by impedance of the circuit. But in resonance, the impedance of the circuit become equal to resistance of the entire circuit R. So P0 is given as 220 here. R value is given as 100. So you will get 2.2 ampere. In this, except that particular vernier calc problem, most of the problems are in the student's range only. Okay, I hope you understand.
I am Nagaraju, senior faculty in Sarat Chandra IIT-JEE NEET Academy. RENEET exam ఏదైతే మన జరిగిందో 31 నుండి 45 వరకు క్వశ్చన్స్ నేను ఎక్స్ప్లెయిన్ చేస్తాను. 31st క్వశ్చన్ నుండి చూద్దాం. A horizontal disc rotating about vertical axis passing through fixed center O. Here we find the LA and LB. Angular momentum for rigid body L is equal to I omega. L is equal to I omega. Here the moment of inertia of the rigid body I is equal to m r square by 2. Here with respect to point A angular momentum we have to find. Here the axis of rotation does not change. That's why angular momentum of A is equal to I omega. Okay. Here moment of inertia is constant and angular velocity is constant. Similarly, with respect to reference point B, this one also moment of inertia is I and angular momentum is omega. We find the ratio of L suffix A by LB is equal to I omega by I omega. That is equal to 1 by 1. That LA by LB is equal to 1. Our answer is 1. Next question, 32nd question. Here the conducting loop of finite resistance lies in xy plane and magnetic field is in z-axis. Here area is varies with time. Here the area is varies with time. We have to find the dissipative power. What is the dissipative power? That power P is equal to E square by R. Here E is the EMF, R is the resistance. EMF E is equal to minus d phi by dt. Here phi is the flux. That flux phi is equal to B dot A. Here magnetic field and area vector lies in z-axis. The angle between B and A is 0. That's why we write B dot A is equal to BA cos 0. That is equal to BA. That flux phi is equal to BA. Here the flux phi is equal to B into this area E changes with time. That is equal to A naught into 1 plus sin t. Okay, we have to differentiate with respect to time. We get the EMF. We have to put the value EMF in power. We get the dissipative power. Here EMF E is equal to minus d phi by dt. That is equal to minus d by dt of phi is equal to B into A naught into 1 plus sin t. We have minus B into A naught is constant. Differentiation of one constant is 0. Differentiation of sin t is nothing but cos t. This is equal to minus B A naught into cos t. This is the EMF E. The dissipative power P is equal to E square by R. That is equal to B square A naught square cos square t by R. That P is proportional to, that power P is proportional to cos square t. Here the graph is written here, power and time. Here cos square graph is changes from maximum to 0 and 0 to maximum. Now our answer is Now our answer is this one. Now our answer is second one. Next question. 33 question. Here a point charge Q is placed inside a cavity. Okay. And also isolated conducting sphere. Okay. We had to find the electric field at point A and point B and point C. Okay. See here clearly. This is point charge Q, which is at a distance A inside a cavity, which is at a distance RA. This field EA is equal to 1 by 4 pi epsilon naught Q by RA square. This is the field inside the cavity. Next, we have to find the electric field for isolated conducting sphere. This conducting sphere having point charge is inside, and due to induction, it becomes minus Q and the outermost charge is plus Q. Here, the 2 points B and C are equal distances. B and C are equal distances. Suppose this is RB, this is RA, this is RC, this is RC. Here the electric field E is equal to, this acts as a outside point. For outside point, electric field E is equal to 1 by 4 pi epsilon naught Q by RB square. This is field at point B. Now the field at point C is 1 by 4 pi epsilon naught Q by RC square. Here RB and RC are equal distance, charge is same. That's why electric field at point B is equal to electric field at point C. Now the answer is, now our answer is E not equal to 0 and EB is equal to EC. This is 33rd question. Next. Here a fixed uniformly charged isolated sphere of charge Q and radius R. A point charge is released at a distance 3r from the center of the charge sphere. The point charge reaches the sphere with speed. We have to find the speed. Okay, see. Here, this is a sphere, isolated sphere. This is a charge Q. This radius is R. Now, a negative charge Q is placed here at a distance 3r from the center of the sphere. First, initially it is at rest. Due to force of attraction, it comes to the surface of the sphere with a speed v. Here we have to write the law of conservation of energy. Here the total energy, suppose this point is A, this point is B. Here we have to write total energy at point A is equal to total energy at point B. Here what is the total energy? Total energy is nothing but sum of the kinetic energy plus potential energy PE. This with respect to reference A. This is the kinetic energy plus potential energy with respect to point B. What is the kinetic energy at point A? Here the velocity is 0, that's why kinetic energy is 0. Here the potential energy is nothing but potential into charge. That potential is at A into this negative charge is minus Q. Is equal to, here the kinetic energy is half m v square plus potential energy is equal to potential at point B into charge Q. Here we write the potential at A is 1 by 4 pi epsilon naught capital Q by this distance is 3r. This distance is 3r into negative charge minus Q is equal to half m v square plus potential at B at this surface. It is at a radius r 1 by 4 pi epsilon naught Q by r into this charge is minus Q. Okay. We have to write this minus charges comes to other side, it is positive. Here we see 1 by 4 pi epsilon naught capital Q small q by radius is r minus 1 by 4 pi epsilon naught capital Q into small q by 3r. This is equal to kinetic energy half mv square. Kinetic energy half mv square. We have to common 1 by 4 pi epsilon naught capital Q small q by r. We have common 1 minus 1 by 3, that is equal to half mv square. This 1 by 4 pi epsilon naught capital Q small q by radius r, this value becomes 2 by 3. This is equal to half mv square. We have to multiply this to this side. This is 4 into capital Q small q by 4 pi epsilon naught into 3r is equal to mv square. Here 4 cancel. V square is equal to capital Q small q by 3 pi epsilon naught r. This into this mass is m. Finally, we got the velocity V is equal to capital Q small q by 3 pi epsilon naught r into m. This is our answer. Our answer is 3. This is final answer. Next 35 question. In Geiger-Melson experiment, the number of scattered alpha particles is along y-axis and scattering angle is x-axis. Here we have to see the formula. Number of scattering particles n is inversely proportional to 1 by sine to the power of 4 into theta by 2. This is the experiment, alpha scattering experiment. Rutherford alpha scattering experiment. These are the alpha particles scattered. This is the gold foil. Most of the alpha particles are scattered in this way. Most of the particles are scattered in this way. Only few comes back and return to the same path. This is called distance of closest approach. Okay, that's why our answer is 3. That's why our answer is 3. Next one. Consider two circuits A and B, each having two resistors. One of them has positive coefficient of resistance plus alpha and other have negative temperature coefficient minus alpha. As shown in the figure, the current through these circuits denotes IA and IB. Yet initially temperatures, the resistance of two resistors is R0. Initial resistance is R0 ఇచ్చడము. If the temperature increases, what is the correct relation ఇచ్చడము? ఇక్కడ చూస్తే మనకి ఇక్కడ here two resistors are in series. That's why R is equal to R1 plus R2. Series resistance in series, R is equal to R1 plus R2. Here R is equal to R0 into 1 plus alpha into delta T is after temperature T degrees delta T. And also R2 is equal to R0 into 1 minus alpha into delta T. This is the resistance R. This resistance R is equal to R0 plus R0 into alpha delta T plus this resistance R0 minus R0 into alpha delta T. This one is negative, this one is positive. That is equal to 2 R0. This series resistance R is equal to 2 R0. Now the current through the A is equal to I is equal to V by resistance is 2 R0. Here there is no temperature. Here the temperature is independent. Okay, that temperature is independent. That's why IA is equal to IA remains constant. We have to see next IB, how to increase. Here these two are in parallel. These two are in parallel. Our relation is 1 by R is equal to 1 by R1 plus 1 by R2. Here R is equal to R1 plus R2 by R1 plus R2. Here we have to substitute these values in R is equal to R1 is nothing but R naught into 1 plus alpha into temperature difference delta T. R2 is R naught into 1 minus alpha into delta T by the two resistance are R1 plus R2. R1 plus R2 we got 2 R naught. R1 plus R2 we got here is 2 R naught. Here R is equal to, this one is R naught, R into R naught square. This is A plus B into A minus B. That is A square minus B square. That is equal to 1 minus alpha square into delta T square by 2 R naught. Here R is equal to R naught by 2 into 1 minus alpha square into delta T square. Here the temperature difference delta T is increase. That's why resistance is decrease. Okay. Now the current passing IB is equal to V by that resistance is R. Here the resistance is decrease, current is increase. Our option is came. See, our option is I1 is constant and IB is increase. Next question. Consider sigma S is the Stephen-Boltzmann constant, KB is the Boltzmann constant, and B is the Wien's displacement law, respectively. The dimensions of sigma S, KB minus 1 and B is reached. Okay, here the Stephen-Boltzmann's law formula is intensity is equal to sigma into T power 4. We have this formula. Now the sigma is equal to intensity by T power 4. Intensity by T power 4. What is intensity? Intensity nothing but energy per unit area per second. We have to write the dimension formula of intensity. Intensity is equal to energy per unit area per second. That energy dimension formula m L square T power minus 2. This T is temperature, A is L square. Our dimension formula is m L0 T power minus 3. This is the dimensions of this is the dimensions of intensity. We got the sigma value I is equal to intensity I naught by sigma is equal to I naught by temperature power 4. Temperature power 4. Intensity value is m T power minus 3. This is Kelvin power 4. This is equal to m T power minus 3 Kelvin power minus 4. This is the dimension formula of sigma. Next one. What is second one? This is Boltzmann constant KB. Okay, from kinetic theory of gases, internal energy U is equal to half KB into T. This is our formula. Here the Boltzmann constant KB is equal to energy by temperature 2U by T గా రాసుకోవచ్చు. ఓకే, ఇక్కడ ఎనర్జీ ఫార్ములా ఏంటంటే మనకి ఎనర్జీ U is equal to this energy Q is equal to E. Whatever may be the energy, E is equal to m L square T power minus 2. Here T is the temperature, write in Kelvin. Here the Boltzmann constant U, Boltzmann constant KB is equal to U by T. That energy is m L square T power minus 2 by temperature Kelvin రాసుకోవచ్చు. This is the KB. And finally Wien's displacement law. Third point is Wien's displacement law. This is first one. This is second one. Third one is lambda m into T is constant. We know this formula. Wien's displacement very, very important for objective and IP. Here this constant is B. This B is equal to lambda m into T. Lambda m into T. Lambda m is nothing but L. Temperature nothing but Kelvin. This is Kelvin. This is constant. These three R's we get. We write the sigma by Boltzmann constant KB into B. This is here written as inversion. I write in denominator. That sigma value is m T power minus 3 Kelvin power minus 4 into B L into Kelvin. L into Kelvin. By Boltzmann constant Kb value is m L square T power minus 2 by Kelvin. Here cancel, L square 1L is cancel, here m is cancel, L power minus 1, temperature power minus 1, Kelvin power minus 2. Here minus plus k is goes to upper side. This k into k square. Here is k power minus 4. We got the this final answer. See once again this answer. L power minus 1, T power minus 1. See L power minus 1, T power minus 1, Kelvin power minus 1. This is final answer. Next question. The electromagnetic wave traveling in a lossless dielectric medium of dielectric constant epsilon naught r is 9. The electric field is E naught into sin kz minus 2 pi into 10 power 6 into t. Here the electric field is traveling along positive z axis. Here electric field is traveling along positive z axis. Okay, which of the following you have to find the incorrect choice? Incorrect. What is the speed of the electromagnetic wave in medium? Velocity in medium is equal to velocity of light c by root of mu r into epsilon r. Here given epsilon r is equal to 9 and mu r is 1. We know mu r is 1. We substitute velocity of light in medium is equal to c by root of 9 into 1. This value is 3 into 10 power 8. This value is 3. That is equal to, this value is 10 power 8. Here the asking question is incorrect. Our answer is correct. Next second one. This is first one. Next second one. What is second one? The wavelength of electromagnetic wave inside the medium is 300 meters. We have to check it. Wavelength, what is the formula? V is equal to n lambda. Lambda is equal to V by n. We know this one is nothing but kz minus omega t. Here the omega is formula is omega is equal to 2 pi n. N is equal to omega by 2 pi. What is the value of omega? That is 2 pi into 10 power plus 6 by 2 pi. This value is 10 power 6. This value is 10 power plus 6. Okay. Here the wavelength lambda is equal to velocity in medium. Velocity in medium value is 10 power 8. Here the value of frequency is 10 power 6. We got value is 100 meters. Here the given answer is 300. This is wrong answer. We have to put the incorrect answer. Okay. This is second one. Third one, magnetic field in this region is given by the relation B is equal to. What is the relation between electric field and magnetic field? Here the electric field E naught is equal to B naught into velocity V. Here magnetic field B naught is equal to E naught by V. Here a given answer is B naught. Here the given answer is B naught by V. We got the value E naught by B. That's why this answer is wrong. Okay, this answer is wrong. We have to put the incorrect answer. These two are. The direction of propagation of the electromagnetic wave is along z axis. This is correct answer. Here asking is incorrect answer. Okay, next question. 1 mole of ideal monatomic gas undergoes a cyclic process as shown in the figure. The total heat supplied. Here the formula is first law of thermodynamics. dq is equal to du plus dw. For cyclic process, internal energy is 0. That's why dq is equal to dw. Here work done is nothing but area under PV graph. area under free week of. We have to find this area is, that is nothing but heat, the total heat supplied. That area is nothing but work done is equal to area. This is a rectangular, that is equal to length into breadth. Length into breadth. Here the length is, here is 2, here is 5. The difference is 3. This is length. This breadth is, this totally 300, this one is 100. The difference is 200. That is equal to 600 joules. Our answer is 3. Next question. Consider electron is revolving excited state of hydrogen atom with velocity 25.6 into 10 power 5 meter per 10 power 5 meter per second. The radius of the orbit is, here the asking is radius value. Here the mass of electron, generally you have to take 9.1, here is given is 9. Charge of electron minus 1.6 into 10 power minus 19 coulomb. 1/4% generally we know. Okay, here this is nucleus. Electrons is revolving in circular orbits, different circular orbits. If the electron is excited state, electron is revolving in excited state. Here two forces are acting. One is charge is revolving in this direction, in this way, e path. Okay. Here two charges, we have two charges. That's why two charges and some separation is R. We have to write the electrostatic force. That electrostatic force is equal to, F electrostatic force is equal to 1/4πε0 Q into Q by this separation is R, that is equal to R square. And also this charge is revolving in circular path. This force acts as a centripetal force. This centripetal force Fc is equal to mv square by R. Okay, these two forces are balanced, then the charge particle is revolving in circular paths. Here the centripetal force mv square by R, here these two forces are equal. F centripetal force is equal to F electrostatic force. That force Fc is equal to mv square by R. That gravitational force, electrostatic force is 1/4πε0 Q square by R square. Here R is and R is cancelled. mv square is equal to 1/4πε0 Q square by R. We have the value of R is equal to 1/4πε0 Q square by mv square. We have all the values, substitute these values. Here 1/4πε0 value is 9 into 10 power 9. Charge value is 1.6 into 10 power minus 19 whole square. By mass of the electron, here is given is 9 into 10 power minus 31 and velocity is 25.6 into 10 power 10 we have to write. We have to squaring the velocity v square. Here root value is root of 25.6 into 10 power 5 is original answer v, velocity v. We have to squaring, okay, 25.6. Finally it came 1 into 10 power 9. 1 into 10 power 9. 1 into 10 power minus 9. The value is 1. Here this value is minus 1. All are cancelled. 16, 2.56. These two are cancelled. Finally, we got the answer 1 into 10 power minus 9. 41. No? A car travels on a circular track of radius 50 meters, which is banking at angle theta. This car travels at a speed 10 meters per second. Wear and tear is of this tire is minimum. Here wear and tear is minimum, nothing but there is no frictional force. Here the what is acceleration due to gravity is, here is given is 10 meters per second square. What is the value of theta? Okay. This is the angle of inclination theta. This is angle of inclination theta. This is car. The force which is normal to the force which is normal to the point of contact of the surface. This is normal reaction N. This mass mg acting vertically downwards. Here this angle theta, this angle also theta. That's why this component is mg cos theta. This component is mg sin theta. Here angle is theta. This normal reaction makes an angle theta. This one is n cos theta. This one is n cos theta. Here normal reaction n cos theta balance the weight mg, and n sin theta balance the centripetal force. Okay, here n cos theta is equal to mg. Similarly, this mg sin theta, n cos theta is equal to mg. This mg sin theta, n cos sin theta, this is n sin theta, this is n sin theta. This force balances the centripetal force. That centripetal force n sin theta is equal to mv square by r. We have to divide these two equations. Sin theta by cos theta is tan theta. Tan theta is equal to v square by rg. Here this numerator and denominator mass are cancels. Tan theta, here velocity is given is 10. Tan theta is equal to 10 square is nothing but 100. Radius is 50 into g is 10. That is equal to 100 by 500. That is equal, tan theta is equal to 1 by 5. Theta is equal to tan inverse of 1 by 5. Okay. Here n sin theta balance the centripetal force. That force is equal to mv square by r. Similarly, n cos theta is equal to mg. We have to divide, we got the answer theta angle. Next, 42 question. Okay. Here, three identical PN junction diodes D1, D2, D3 are connected across the battery as shown in the figure. The width of the depletion layers, D1 diode is W1, D2 diode is W3, D3 diode is W3. Okay, then the correct option is here. This one is width of the depletion layer is W1, this is W2, this is W3. Here it is in reverse bias. This is negative, this is positive. But this diode D3 is reverse bias. Width of the depletion layer is more for all. Okay. For diode D1 is width of the depletion is very much less. That is W1. In between unbiased diode is middle. Unbiased diode is middle. We have answer is 3. We have the answer is 3. Next one. The following table represents the part of the electromagnetic spectrum and their corresponding major application. The part of the electromagnetic spectrum applications. Microwaves are used for warming the food. Next one, ultraviolet rays purifying the water. And next one, this one is microwaves is 2 and ultraviolet rays is 1. Gamma rays are for treatment of cancer. Radio waves are for AM and FM communications. That's why our answer is third. Next, 44th question. A bulb of mass m is rest vertically from the ceiling of a ceiling via massless spring of length L. L is equal to 10 centimeters. As shown in the figure, a point mass of m is traveling with a velocity v. This velocity is v. Okay. The bulb rises h meters after the collision, taking the acceleration due to gravity g. Neglect the size of the bulb, the value of height. Here, law of conservation of energy. Here, initial kinetic energy is converted into potential energy. Here, the kinetic energy is half mv square. Here, kinetic energy is half mv square. This can be converted into potential energy mgh. Here, mass m is cancelled. Okay, we have to find the velocity. V square by 2 is equal to gh. This height h is equal to v square by 2g. That velocity v square is equal to, here the value of velocity is given is 10 square, that is 100. This 2 into g value is 10. That is equal to 100 by 20. That is equal to 5 meters. Okay, our answer is 3. Our answer is 3. Next, see our last question 45. See once again 45. Okay, an ideal gas is made up of polyatomic molecules. Each of molecules has 3 translational and 3 rotational and f number of vibrational modes. The ratio of Cp by Cv gamma is gamma is equal to 8 by 7, the value of gamma. Here we know CV is equal to FR by 2 and CP minus CV is equal to R. Now CP is equal to CV plus R. That CP is equal to CV is FR by 2 plus R. We have to take LCM is 2. This is FR plus R. We have to common F plus F by 2R. F by 2. This is R by 2. This is CP value. Here the gamma value is gamma is equal to CP by CV. This CP is F plus 2 by 2 times of F by FR by 2 times of R. This one is R. This R, okay. R by 2 is cancelled out. F plus 2 by F. Okay. Here gamma is equal to F plus 2 by F. Gamma is equal to 1 plus 2 by F. Here gamma minus 1 is equal to 2 by F. Okay. Here F is equal to 2 by gamma minus 1. 2 by gamma minus 1. This is the degree of freedom. Here 3 translational means, okay, see once again, here 3 translation means degree of freedom is 3 and rotational, so 3 rotational modes, F degrees, F vibrational modes. For 3 translation modes, degree of freedom is 3. For 3 translation modes, for 3 rotational modes plus 2 vibrational modes, this is equal to 2 by gamma minus 1. Okay, totally it is 6 plus 2R. Why you have to write here it is 2? One is potential energy, another one is kinetic energy. That's why you have to write 2F. That is equal to 2 by gamma minus 1. Okay, 6 plus 2F is equal to 2 by gamma is equal to 7 by 8. What is the value of gamma? Is equal to 8 by 7. Gamma is equal to 8 by 7 minus 1. That is equal to 2 by 8 minus 7 by 7. That is equal to 2 by 1 by 7. That is equal to 14. Here 6 plus 2F is equal to 14. F is equal to 14 minus 6. That is equal to 8. 2F is equal to 8. That F is equal to 4. Okay. Our paper is completed. Thank you.